Hi guys! So today we are moving out of our factoring process and we are going to jump into what we call quadratic functions. These are your U-shaped items, and so we are going to identify key features today. So some key features that you want to make note of are that you have a U shape. And for that U shape, we have a couple of things we want to identify, such as the domain. And the domain is how far left the function goes to how far right the function goes. So according to this U shape, this branch over here on my U shape is the far left. And that left just keeps going and going and going. So the domain on the far left-hand side of a U shape is going to continue towards the negative numbers infinitely. So we call that negative infinity. And we use a parenthesis because you can't be at infinity. It just keeps going and going. All right, so same idea on the far right-hand side of the U shape. We are also going up more and more and more and more, which means that there is no stopping me in going in the right direction or in the positive numbers infinitely. So we'll use positive infinity to denote that we can just keep going and going and going in our U shape. So that is the domain. Domain is left to right. Okay, now let's talk range. These words may come back to you a little bit here. Range is how low do you go? So how far down does my graph go? Well, according to this U shape, the lowest I am at is down here at -9. So -9 gets a bracket. So this symbol, that is a bracket, which means I can touch -9. It is my lowest point on my graph. And how far up does the U continue to go? Well, the U keeps going and going and going and going and going infinitely up. So infinitely upwards or towards the positive numbers as I keep getting bigger and bigger and bigger. All right, so that is domain and range. So domain is how far left to how far right. Range is how low to how high, so from the bottoms up. And please make sure that you use a bracket when I can be at the point. And you will always use parentheses around your infinity because I can't touch infinity, unfortunately. All right, so the next feature we want to talk about is what we call the vertex of the quadratic. And the vertex is going to be this box over here. So I am going to jump around just a little bit. The vertex. We also call the vertex either the minimum or the maximum, or most people will abbreviate that as min or max. And this vertex is the lowest point if it is the minimum, or it is the highest point on our graph. And if it's the highest point, we call that the max. Now, for the vertex, oh, you can't even see what I'm writing. I'm sorry. There we go. So the lowest point is called the minimum. The highest point is called the maximum on our graph. So it depends on what you see. And we write the point as x, y, like an ordered pair. So as we look on our graph, we have a vertex that is the lowest. So we have a vertex point right here. And where is that located? Well, our example is a minimum as a vertex. And our point for the vertex of this question is located from 0 to the right 1. So my x is 1, and I'm located down 9. So my y value is 9, negative 9, sorry. So my minimum value is negative 9, the lowest I can be. Now, another piece that comes from the minimum or maximum, or what we call the vertex, is what we call the axis of symmetry, or we call this the AOS. So up here at the top, we call this guy the axis of symmetry. And it's exactly what you think it is. Symmetry means that you can map me onto myself, or you can fold me to make equal halves. So an axis of symmetry is where I can fold so that I'm literally halfway through my U shape. So what is an axis of symmetry? Well, as you notice, this folding line that I can fold in half is a vertical line that cuts the quadratic function in half. Literally, it's smack dab in the middle. And notice that the AOS, or the axis of symmetry, also holds the vertex. So if you find where the vertex is located, the axis of symmetry will be the vertical line through that point. Now, we always write this axis of symmetry as x equals the number that you're slicing through. So our example is slicing through the x value of positive 1. So vertically, our axis of symmetry is x equals 1. All right, 2 more to go, guys. We are going to talk about the x-intercepts next. So x-intercepts, the words literally give it away. The x-intercepts, guys, are where I touch the x-axis on the U shape. But before we get that far, we also have a few other words that we call these. Not always do we call them x-intercepts. We can also call them roots. We can call them zeros. Or we can call them solutions, just like how we had all real solutions or no solutions when we were solving our equations. Okay, so it is written in 2 possible ways. You can write them as points off of the graph, or you can write them as x equals, which is more like a solution, like what you solved for x. So as you look at your U shape, here is my x-axis. It's labeled as x. Our x-axis, where does my U shape cross that line for my x-axis? Well, I cross here at -2. So -2, 0 means that I'm on the x-axis. And I'm also over here at +4, 0. Or we could write those solutions as x equals -2 and x equals +4. They mean the same thing. So our x-intercepts, roots, zeros, or solutions mean all the same thing. It means where does my U shape hit my x-axis? All right, now we have one more intercept to talk about, and it's the y-intercept. And this is the point where the graph goes through the y-axis. So let's take a look at our U shape. Here's my y-axis. So where does my u hit that vertical line here of my y-axis? Well, it hits me right here. So this is our y-intercept. We did not move any from left to right. So our coordinate would be 0, comma, and then how far down did we go? We went down -8. So our y-intercept is a point. So you're going to write it literally as a point on the y-axis. So those are your key features of our parabola or a quadratic. And so now let's do one more example, and then you guys are going to practice a little bit for us. So example number 2 is down here at the bottom. So let's quickly identify some of these pieces. So first and foremost, let's talk domain and range. So domain, how far to the left does this parabola keep going? Well, it keeps going forever and ever and ever and ever and ever. So the domain is still going to be negative infinite numbers all the way to the left. And this U-shape continues all the way to the right, infinitely positive. According to those arrows, it means I just keep going and going and going and going. The range, however, is how low to how high, or how far down to how far up. So looking at our U-shape, we keep going down and 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 down infinitely. So our range is going to start from negative infinity, comma. We're going to work our way up to the highest point, which will be our vertex here in just a little bit. So the range is from how low, which we're in the negatives, and we're coming up to the y value here. How high am I on the graph? Well, I stopped at the x-axis, which means I stop at 0. I don't go past 0. And since I can be at that point, we are going to use a bracket. Okay, now let's talk vertex again. Well, we kind of already identified that our vertex is the highest point, which means that this guy is a maximum, and its location is over +3, and we didn't go up or down any, so 0 movement up or down. Now remember, your AOS, your axis of symmetry, where you split the U in half, literally goes through that vertex point. So that dotted line is our AOS. So what X value is that cutting through? Well, it's cutting through the X-axis here at 3. So X equals 3 is your axis of symmetry. All right, 2 more pieces to go. The roots. So we use this word root, which means find me the x-intercepts. So how many times do I cross the x-axis? So we're going to look at the x-axis here. Oh, we only hit 1 time, and it's also our vertex point. So we don't have a second root this time. We only have 1, and that happens sometimes, depending on how the U moves and takes shape. All right, so our root is over 3 and up and down nothing. It's a point on the graph. But what about our y-intercept? Well, to find our y-intercept, we need to be on the y-axis. So we're going to follow that y-axis line down, and it looks like our U-shape crosses right here at this point at -18. So we did not move left or right any for that coordinate. We just went straight down to 18. So our y-intercept is 0 down to 18. So comma -18. All right, it's time to practice.